In this lesson, we're going to focus on plotting points on the coordinate plane and the vocabulary that goes along with mathematics and the coordinate plane. So the coordinate plane is used for graphing in the math world. And essentially how this coordinate plane was created is it's an intersection of a horizontal number line. You can see that here. And a vertical number line, which you can see here. So we have a vertical number line, a horizontal number line, and then they form this grid between the different points, and this is what we call the coordinate plane. Now on the coordinate plane, we have a couple of key areas that we need to be aware of. The first is called the x-axis, and the x-axis is the horizontal number line on the coordinate plane. So this piece right here, this horizontal number line, is called our x-axis. Then from here, the y-axis is our vertical number line on the coordinate plane. So this piece right here is called our y-axis. So when we refer to a point falling on the x-axis or the y-axis, we're referring to a point on that horizontal number line or that vertical number line. So the origin is another important point on our coordinate plane, and it is where the x-axis, which remember is right here, and the y-axis, which remember is right here, meet. And if you look very, very carefully, there's only one point where these two lines meet. And it's right here in the middle at this point called the origin. So that is our origin point. Now, this origin point has a very special coordinate to it, and it's the coordinate 0, 0. And we'll talk about what those coordinates represent in just a second. Then from here, the coordinate plane is divided into 4 main quadrants. So we have 4 main quadrants. Quadrant 1, and I'm going to use Roman numerals to represent this. Quadrant 1 is right here. That's where we have x is positive, y is positive. Quadrant 2 is right here. That's where x is negative, y is positive. Quadrant 3, we go counterclockwise here. X is negative, y is negative. And quadrant 4 is where x is positive and y is negative. So we have 4 quadrants on our coordinate plane, and they go in counterclockwise order, starting in the positive quadrant. Then from here, every point on the coordinate plane is represented by an x, y ordered pair. So what that means is you're finding the meeting point of a number on the x-axis and a number on the y-axis. So here, say we had the point -6, 2. So what we're looking for here is we're looking for the intersection of where x is -6, which we can see right here, x is -6, and y is 2. We're looking for that intersection point. And what you see is where x is -6 and y is 2, we find a point. And that point is the coordinate x is -6, y is 2. So we can represent data on the coordinate plane by using x, y ordered pairs. So what we're going to do on this slide is we're going to match the ordered pair to the points on the grid. Then we're going to identify the quadrant the point is in. So here we start off with x is -3, so I go to where x is -3. And y is -5, so I'm at x is -3, and I'm going down to y is -5. You can see that right here. I know that that is point D. Then remember our quadrants go 1, 2, 3, 4. So I see that D is in quadrant, that's a Q, 3. Then from here I move on to the next point, and I'm trying to find, okay, x is 4, so 1, 2, 3, 4. And then from here, I'm finding x is 4, y is 7. So 1, 2, 3, 4, 5, 6, 7 here at point B. And point B I can see is in quadrant 1. Then I move on to the next point, and I see x is 1, 2, 3, 4. And y is 1, 2, 3, 4, negative 5. So here I can see, okay, y is negative 5, x is 4, occurs at point C, and that's in quadrant 4. And then from here, the last one, x is negative 1, 2, 3, and y is a positive 7. So 1, 2, 3, 4, 5, 6, 7. So that's point A, and that is in quadrant 2. So now what we're going to do on this slide is we're going to graph the points below, and then we're going to identify if the point is located in a quadrant, and which quadrant, on an axis, and which axes, or the origin point itself. So we're going to start with point A. That's where x is 0 and y is 1, 2, 3, 4, 5, 6, 7. This is point A. What I notice about point A is that it's not necessarily in a quadrant. It looks like it's between quadrant 1 and quadrant 2, which doesn't really help. But what I also notice, since I can't pick a quadrant, is that it's located on one of the axes, and specifically it's located on the y-axis. Then I'm going to move on to point B. X is 0, y is negative 1. So that's down there at point B. Point B, I notice I have the same dilemma. It's not really in a quadrant, but it's on the line. So that again is on the y-axis. Then I go to point C, which is at 0, 0, which I notice isn't in a quadrant because it's basically kind of touching all four. And then it's touching both axes. So that isn't really in a quadrant or an axis. It's more specifically at the origin point. Then from here, I'm going to do x is 1, 2, y is a negative 1, 2, 3, 4, 5, 6. So there's point D. And point D is very clearly falling in quadrant 4. Then I'm going to point E. Point E, if I look at it closely, it's going to x is negative 9. So x is negative 1, 2, 3, 4, 5, 6, 7, 8, 9. So it goes off the graph a little bit. That's point E. Point E, I notice, isn't occurring in a quadrant at all. It's on this line here, and it's specifically on the x-axis line. Now from here, I'm going to move forward and I'm going to do point x is 1, 2, 3, 4, 5, and then y is negative 1, 2, 3, 4. So that's where point F is. And point F, I notice, is very clearly in quadrant 4. Then from here, I'm going to try the next point. What I see is I'm going to x is negative 1, 2, 3, and then y is negative 1, 2, 3, 4, 5. So there's point G down there in quadrant 3. And then lastly, I have x is 1, 2, 3, 4, 5, y is 0 for point H, and that one is on the line, so I will say it is on the x-axis. All right, so here we're going to apply the coordinate plane a little bit by checking off these 6 steps. So here, the first one says to label each point as an ordered pair. So starting up here at point B, at point B I see that x is 4 and y is 7. That's the meeting point of x is 4, y is 7. Point A is the meeting point of x is negative 3, y is 7. Point D is the meeting point of x is negative 3 and y is negative 5. So negative 3, comma, negative 5. And then point C, is right here, is the meeting point of x is 4 and y is negative 5. So I took care of this first one, labeling them as ordered pairs. The next piece says to connect A to B, B to C, C to D, and D to A. And it asks me what shape this makes. And this makes a rectangle. I can see it. I have 4 nice right angles and 2 pairs of equal sides. So that checks off number 2. Now we're going to focus on part 3. And part 3, 4, and then we can apply the rest. Says, what is the difference from A to B and B to C? So A to B is 1, 2, 3, 4, 5, 6, 7 units. B to C is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units. And then here, because this is a rectangle, these would be the same on those opposite sides. Then it says, find the perimeter of the shape. Remember, the perimeter of the shape is when you go around the outside of the shape. So we're going to add those 4 sides together. So 7 plus 12, those first 2 is 19, plus another 7 is 26, plus 12 is 38 units. And then from here, we need to find the area of the shape. Well, since it's a rectangle, I know area is length times width. So here my area would be 7 times 12. And 7 times 12 gives me 84 units. And because it's area, it will be squared. And last but not least, we're going to apply the coordinate plane to the expressions we've been working to so far. So this says, evaluate the expression for when x is equal to -3, -2, -1, 0, 1, and 2. So essentially, you're going to evaluate this expression 6 different times for 6 different values for x. You're then going to use the results in part A to write a list of ordered pairs in the form x, comma, 2x minus 1. So I'm going to explain to you what I mean by this a little bit more. So I'm going to make a table. It's not going to be x and y, though. We'll use those when we get to graphing a little bit further in the course. So this is going to be x and then 2x minus 1. So when x is -3, we're going to evaluate that in terms of 2x minus 1. So we have 2 times -3, then minus 1. 2 times -3 is -6 minus 1, which is -7. So our first coordinate is -6, comma, -7. Our next one is -2. So we have 2 times -2 minus 1, which is -4 minus 1, which is -5. So here we have -2, comma, -5. Then I have -1. 2 times -1 minus 1. -2 minus 1, which is -3. So that next point is x is -1, and 2x minus 1 equaled -3. X is 0, so we have 2 times 0 minus 1, which is 0 minus 1, which is -1. So the point x is 0, and its corresponding number with the 2x minus 1 is -1. Then we have 1, 2 times 1 minus 1, so that's 2 minus 1, which is 1. So then we have x is 1 and 2x minus, x is 1 and 2x minus 1 is also 1. Then we have 2, so that's 2 times 2 minus 1, which equals, the marker's running out a little, but we have 4 minus 1, which is 3. And as a result, we have x is 2 and 2x minus 1 is 3. So the last piece here is once we have all these points, we're going to plot them. So x is -3, y is -7. Then I have x is -2, y is -5. X is -1, y is -3. X is 0, y is -1. X is 1, y is 1, and x is 2, y is 3. So again, just another application of how we can apply coordinates and tying it in with our use of math expressions and evaluating math expressions.